Hello, good morning, everyone. Sorry for the delay. We will be starting our session now. For today's first section, we have Dr. Aditi Sharma over here. So, I will give a brief introduction of who is Dr. Aditi Sharma. Aditi Sharma received the BTech degree in Computer Science and Engineering from Modi Institute of Technology in Lakshmangarh in 2008. She received her PhD from MBM College Engineering, JNVU, in 2018. She has published around 122 research papers in international journals, SCI, ESCI, Scopus, and national international conferences, and authored 6 books. She has published 10 patents and also having 20 patents in her grant. Uh, Her research area includes cryptography, blockchaining, VLSI, cellular automata, machine learning, AI chatbots, IoT, and artificial intelligence. She is serving as conference chair, general chair, technical program committee member, and a reviewer in various Springer, IEEE international conferences, CSNT 2022, DASA 22, IAICT 2022, AIARS 2022, ISI 2022, ICC AIS 2021, ICDSI 2020, IAPCS 2020, ICSCLM 2017, INAIT 2019, Global Open Online Conference System, WCI 18, and many, many more. She achieved many awards and scholarship during NAV Shakti Award by Northern Eastern Council, Ministry of Do NER, Government of India. Pravati Chand Devi and Gargi scholarships and awards from Madan Lal Khurana, Sunil Dutt, APJ Abdul Kalam. She also got Best Teacher Award by Rajasthan Patrika Group. I will be now handing over to Dr. Aditi Sharma for further taking the session.
Thank you so much, sir. Thank you, sir, for the opportunity and the introduction. Let me share my screen first. Is my screen visible to you? Hello? Hello? Am I audible? Yeah, okay, thank you.
So, uh, good morning, ma'am.
Good morning, sir.
Yes, yes. Nice to see you here again. Yes,
Yeah, me too.
it's great
So,
privilege for us to be get you an expert lecturer at this FDP at EICT.
um, actually, like because of this type of lecture, I have to learn so many things.
Yes, yes, yes. Definitely.
Okay, so let me share my screen and let me start. Hope is this visible to you?
Yes, this is visible, and you maximize the screen. Yes.
Right. Yeah. So I have just to summarize the blockchain implementation in the healthcare 5.0. I'll start with the introduction of the blockchain and what is the actual conceptual understanding as I have seen in the past that till now what has been covered in the FTP. And after that, I'll give you an idea how we can implement this blockchain in healthcare 5.0 with the integration of AI and ML both. So here, when we are starting with the blockchain, so blockchain was introduced in the terms of the Bitcoin. That terms came after the introduction of the Bitcoin. That was the distributed ledger. As in the past era, we were on the books that was accountable and the form in the ledger, and each accountant has to maintain some kind of registry in the laser. So this laser was already distributed. Now we have what we have done, we have implemented online distributed laser, and that Bitcoin, that was the cryptocurrency, first cryptocurrency, and it is started from the specific kind of distributed ledger, that was the blockchain. So It is like when we are talking about blockchain that keep thousands of strangers honest and the consistent, because there is no role of the third party trust. Then here, what exactly the things was covered as the distributed ledger, that it was the open distributed ledger which was like P2P permanent. And there are several agency who has come around the world and given the idea of different kind of ledger. And after that, what kind of expertise you needed, like advanced networking, vulnerability assessments, course development, cyber exercise and training, computer network defense, legacy system security training, and microelectronics. So how this distributed laser technology is working, that it is called as a software protocol. What we are maintaining, we are maintaining a chain of blocks, and maintaining in the software terms. So this is just a SMTP is a protocol for sending email. Blockchain is a protocol for sending money. So that is moreover the terms of the transaction. Transaction in terms of money, transaction of any record, anything, but we need to propose the transaction in this. So here, a major thing was implemented for the supply life cycle management. If I'll talk about the there are like Ola, Uber party or other parties. So there is a customer which is struggling with the third party trust. Okay, so here what we have to see, that if buyer one is there, then it needs validation for 1 year. Buyer two is there, then it needs almost 2 year validation, and buyer three is required for the 6 month validation. So when there are the multiple changes there and the supplier is the same, so and different buyers have to optimize the same technology. So there is different kind of timing which is required for the supplier and the between the buyers to acquire the things happen. So here, Bitcoin was proposed by the Satoshi Nakamoto in the terms of a paper that was given as brief idea how the electronic cash will be transit into the online payments, and will going to send directly one party to another without going through a financial institution. So this is an open distributed ledger that can record transaction between two parties efficiently and in a verifiable and permanent way. So this is open distributed ledger P2P permanent, and blockchain technology is expanding significantly. So it was like a Bitcoin white paper was introduced in 2008 to October, and most associated blockchain technologies came across as the cryptocurrency lasers, and that was like Bitcoin, Ethereum, Dcash, Zcash. So we have different kind of application and domains where like networks, application, agreements, and the proof of ownership. So the theory behind Bitcoin was first explained in 2008. That was the white paper where the idea was conceptualized by the Satoshi Nakamoto. And after that, blockchain 1.0 was moved as the blockchain 3.0 with the inception of the Web 3.0. So it is like when we are talking about the blockchain 1.0, it was like digital currency. When we are talking about the blockchain 2.0, that it is the digital finance, and blockchain 3.0 is the digital society. So blockchain is a list of records that are the calling the blocks that store data publicly and in chronological order. So the information is encrypted using cryptography to ensure that the privacy of the user is not compromised and data cannot be altered. Information on a blockchain network is not controlled by a centralized authority, unlike modern financial institutions. If you are a participant in the blockchain network, you will have the same copy of the laser. It means what you are doing, the laser is maintained by the supplier and by the customer itself. There is between the chains, we do not have different participants which do have other entry of the laser. So whatever the entries of the laser or the copy of the ledger is provided by the supplier, it is having the same copy by the all the participants. Even if one node or data on one particular participant computer gets corrupted, the other participants will be altered immediately, and they can rectify it as soon as possible. So when we are talking about the conceptual understanding, so we can say that it is a decentralized database. There is now we have demised the concept of the centralized database and peer-to-peer network that stores a registry of transaction secured with the cryptography. Blockchain is the ledger or record keeping side of transaction and subsequent transaction. In simpler terms, blockchain technology uses a distributed database not connected to a common processor that organizes data into records that have cryptographic validation or time stamped and are linked to previous records, so they can only be changed by those who own the encryption keys to write the files. Blockchain records the data, date, time, participants, and any other contextual or legal pieces of a Bitcoin transaction. So, blockchain is a key part of infrastructure underlying Bitcoin and other cryptocurrency. So when we are saying that I can take an example of the linked list. Okay, so where we have different nodes, and those nodes are having the pointer connection, and those nodes and entries are stored in the previous nodes. So this is a like a chain. So here in the blockchain technology, what we are following a structure that stores transactional records, also known as the block of the public in several databases, known as the chain in a network connected through peer-to-peer nodes. Typically, this storage is referred to as a digital ledger. Every transaction in this ledger is authorized by the digital signature of the owner, which authenticates the transaction and safeguards it from tampering. It means what we are maintaining the authenticity. If owner has not signed this particular transaction or particular ledger, so the customer and the participant will have the knowledge that it is a tamper data which is not authorized by the first party. Hence the information the digital ledger contains is highly secured. So in the simpler words, the digital ledger is like a Google spreadsheet shared among numerous computers in a network in which the transaction records are stored based on actual purchases. It means you can recall the history. The fascinating angle is that anybody can see the data, but they cannot corrupt it. So, when we are talking here, we can see that a blockchain provides a mechanism to distribute digital information and decentralize security. So, when a server is established across the US, it can decentralize the different server across the world. So here, blockchain introduction, the blockchain becomes a decentralized database with all transactions that have occurred up that point. Each blockchain has a specified time between each new block. After the block time has been reached, all new transactions during that time are added to the hashed value of the previous blocks. Likely in the linked list, what we are doing here, we are providing the hash value for the previous blocks. Transactions are only added after network consensus is raised. So here we can see how does a blockchain work. Like a user is requesting for a transaction. A block representing the transaction is created. The block is broadcasted to all the nodes of the network. After that, all the nodes validate the block and the transaction. The block is added to the chain. The transaction gets verified and executed. What we are doing, we have to create a transaction request. It means if I have to design an algorithm, so I have to design an algorithm in that way that a user is intended to request a transaction. After that, a block is have to represent the transaction is created. It means I have to write the code in which I have to create a transaction. The block is broadcasted to all nodes of the network, whether you are using the cloud, whether you are using the private or public cloud. So this block has to broadcast to all nodes of the network. It means there is a network, what you have designed earlier. After the transaction request has been received, this transaction request is going to provide a transaction into the block, and this block is going to broadcast to all the nodes. All the nodes validate the block and the transaction. After that, the block and the nodes, all the nodes, whatever is connected to the decentralized database, are going to provide the block and the transaction. The block is added to the chain, the transaction gets verified and executed. So, what are the remarkable benefits of the blockchain technology? That it is a faster settlement. That why was faster than the manual process of the validation? Because once it is authorized, then there is no need of again and again validated. So, immutable. It means the transaction cannot be undone if they are already in the blockchain. It means nobody can tamper the data. Shared and distributed blockchain technology offers a shared and distributed ledger that is open for all the users. Decentralized, not dependable on the server based technology, and no one has authority over the system. So, more secure, much safer than the traditional methods. Increased network capacity, much more capable than the traditional network. So here, what we can see, we have a different type of blockchain network where we have main network as a public versus private blockchain network. So public blockchain are the permissionless and the private blockchain are the permission. When we are dealing with the permissionless and open network system where all the devices can freely access without any kind of permission, the ledger is shared and the transparent. It means there is no kind of restriction in on the devices. Okay, so this laser is shared. Private blockchain, that are the permission, and a user has to be permitted by the blockchain authority before he or she should access the network. The user might join only if he or she gets an invitation. Here we can see centralized network, decentralized network, and the distributed network. All the nodes are connected under a single authority. In the centralized network, star and the mesh topology, what already we have seen in the topology, we have followed the same structure in the network strategy in the blockchain. So decentralized network, no single authority server controls the nodes, they all have individual entity. Distributed network, every node is independent and interconnected with each other. That is having the fast transaction, but it requires more resources. So here we have some few blockchain terms like airdrop, altcoin, Bitcoin, DAO, DApp, ERC, Ether, fiat, and then ICO, then 51% attack, utility token, DYOR, POMO, and FUT. So these are the famous blockchain terms when we are talking about airdrop. That is the process of distributing free cryptocurrency coins to the general public. Altcoin is any cryptocurrency other than Bitcoin. Bitcoin, it was the first cryptocurrency that came into existence in 2008-9 by Satoshi Nakamoto, and it is a digital currency that doesn't require a centralized authority to work or function. DAO is the decentralized autonomous organization which is going to authorize your transaction. DApp, that is the decentralized application that runs without the control of a central authority. ERC20 is a technical standard for issuing tokens on Ethereum blockchain. Ether is a fuel that powers distributed Ethereum network. Fiat is the government controlled currency and is declared as a legal tender. ICO is the initial coin offering that is used by startups to raise funds by selling tokens. Mainnet is a working blockchain product that also provides the ability to transfer digital currency between users in a blockchain environment. 51% attack is a common vulnerability with blockchain technology. It can be exploited by a group of miners if they control 51% of the hash rate of the whole network. Utility token, that is the token that has a utility attached to it, and that are used for accessing a product or service. DYOR, do your own research. FOMO, fear of missing out. FUD, fear, uncertainty, and the doubt. So here we can see the three pillars of the blockchain: decentralization, transparency, and immutability. So when we are talking about the decentralization, so whenever I have to provide a program or I have to design an algorithm, so I have to design a decentralized network. If you want to interact with your friend, then you can do so directly without going through a third party. That was the main ideology behind Bitcoin. You and only you alone are in charge of your money. You can send your money to anyone you want without having to go without a bank. So this is like the decentralized network. When we are talking about the transparency, one of the most interesting and misunderstood concept is the transparency. A person's identity is hidden by a complex cryptography and represented only by their public address. Here we can see the Ethereum transaction. So what we are seeing, that everyone has been assigned as a public address. Now every entity is going to be identified by the public address, not by their original identity. So here we are following the transparency, but the particular identity is hidden by their public address. So here we can say see that here is a transaction hash blocks, and what is the age of this block, because time matters in the blockchain. Then from, so here is the from address, which is the public address actually, and whom it is designated to transaction. So we have the two. Then we have the values. So immutability in the context of the blockchain means that once something has been entered into the blockchain, it cannot be tampered with. The reason why the blockchain gives this property is that of the cryptographic hash function. So here we have the simple terms. Hashing means taking an input string of any length and giving out an output of a fixed length. So here what we are doing, we are providing the concept of the immutability. Like once whatever we are entering, it cannot be tampered, as it is decoded in the hash value. So now we can see what exactly is a block. I have already talked about the block, how we are doing in the linked list as in the terms. So what we are here doing in terms of the block. So each phase in a ledger of transaction forms a block. So you can imagine, like there is a pages in the ledger, in the hard copy ledger. Okay, every page having some entries, second entry in the second page, and third, and first is the index. So here what we are doing, so each page in a ledger of transaction forms a block. So what we have to design, that every block is a page in a ledger. Okay, and that contains a transaction what we have previously seen. The block has an impact on the next block or page through cryptographic hashing. It means every block is connected to some hash value which is assigned with the cryptography. In other words, when a block is completed, it creates a unique secure code which ties into the next phase a block, creating a chain of blocks or blockchain. So here what we can see in the diagram, there is a block one transaction, that is block 2 transaction and block 3 transaction. Okay, and every block is connected to the next block. So here we have block 1 header, then hash of previous block header, then Merkle root. Here second, in the second block header what we have seen, hash of previous block header, then Merkle root, and then block 3 header, hash of previous block header, and then Merkle root. So, what is lasers? Centralized, decentralized, distributed lasers. And the new networks, distributed lasers can be public or private and vary in their structure and size. And the public blockchain require computer processing power to confirm transaction. So, when we are just analyzing power of confirming the transaction, that is called as the mining. Okay, so here we can see in the distributed laser that we have two types of users. In the red dots, we these are the anonymous users, and in the blue dots, these are the not anonymous user. So in the anonymous user, each user has a copy of the laser and participates in confirming transaction independently. In the blue dots, we have seen permission is required for users to have a copy of the laser and participate in confirming transaction. So, like what we have seen that what exactly is the distributed laser. So, in the distributed laser, we have a database. It means we have to create a database that exists across several locations or among multiple participants. Centralized laser, all parties reconcile their local database with the centralized electronic laser that is maintained and controlled by a trusted central party. So when we are talking about the hello, am I audible? So when we are talking about the distributed ledger, that is a permissionless. Okay, so that permissionless network having the owns a full and up to data copy of the entire laser. Every proposed local addition to the laser by a network participant is communicated across the network to all nodes. Nodes collectively validated the change through an algorithm consistency mechanism. After validation is accepted, the new addition is added to all respective lasers to ensure data consistency across the entire network. So we can see that here we peer-to-peer network owns a full n- and up to date copy of the entire laser. So in the each node having the permissionless laser. Next is a permission laser. So nodes need permission from a central entity to access the network and make changes to the laser. Access control can include identity verification. After that, how this distributed ledger transaction has to work in this blockchain network. So first, blockchain based DLT system takes the form of an appended only chain of data blocks. New addition to the database are initiated by one of the members, that are the nodes, who creates a new block of data containing several transaction records. Information about this new block is then shared across the entire network containing encrypted data, so transaction details are not made public. Here, all network participants collectively determine the block's validity according to a predefined algorithm validation method, that is the consensus mechanism. Only after validation, all participants add the new block to their respective lasers. Through this mechanism, each change to the laser is replicated across the entire network, and each network member has a full identical copy of the entire laser at any point of time. So here what we can see, member A creates new transaction block with the transaction from member A to member B, and here we can see different kind of a mechanism to introduce the laser entries. So when we are talking about the public open blockchains and the permission blockchain, in the central party, there is no central owner or administrator in the open blockchain, and whereas we have the some control and some degree of external administration in the permission blockchain. There is access, anyone can join, only pre-selected participants can join the network. Level of trust, that network members are not required to trust each other. Higher degree of trust among members is required in the permission blockchain. Then openness, ledger is open and transparent, shared between all network members, that is the public blockchain. Different degrees of openness and transparency of the ledger are possible. Then security through wide distribution in a large scale network. Security through access control combined with DLT in smaller scale network, that is the permission blockchain. Then we have the identity, user identity, anonymous or protected by pseudonyms. And here we have the permissioned blockchain that has the identity verification typically required by the owner administrator. We have the consensus that there is a difficult proof of work is required as consensus mechanism in the public blockchain. And here in the permission blockchain, we have the variety of the consensus mechanism possible, typically less difficult and less costly than proof of work in permissionless blockchain. What we have assessed asset, then in the public blockchain, we have the native cryptocurrency, but implementation are possible where a token is used which can represent any asset. Then permission blockchain, we have the any asset. Legal ownership, there is no legal ownership and no legal entry for the ledger in the public blockchain, whereas the greater legal clarity over our ownership, as administrator is typically a legal entity in the permission blockchain. We can see the example as a Bitcoin, Ethereum, or as the public blockchain. R3, Skoda, Hyperledger Fabric are the permission blockchain. So we have seen the Bitcoin term. Now, what exactly is the Bitcoin? That is a cryptocurrency. How this cryptocurrency is made for so far. So it is a form of a digital currency that can be used to verify the transaction of asset, control the addition of new units, and secure financial transactions using cryptography. One of the cryptocurrency most important advantages over normal currencies is that they are not controlled by any central authority. Without a central point of failure or a vault, the funds cannot be hacked or stolen. The shared and distributed nature of the cryptocurrency keeps everyone on the same page. So, therefore, the transparency and distributed nature of the blockchain technology is what makes cryptocurrencies most secure. Some of like Bitcoin, Litecoin, Ethereum, Stellar, and the Ripple are the cryptocurrency. So, like what when we are designing an algorithm for the currency, cryptocurrency, so what you have to you have to design a laser. You have to propose this laser in the distributed network. That database having some kind of transaction ability, and this ability is done into terms of the entry, that is the cryptocurrencies. So we have the nodes as an entry. So this is the most important concept in the decentralization. No one computer or organization can own the chain. Instead instead it is a distributed ledger via the nodes connected to the chain. Nodes can be any kind of electronic device that maintains copies of the blockchain and keeps the network functioning. Every node has its own copy of the blockchain, and the network must algorithmically approve any newly mined block for the chain to be updated, trusted, and verified. Each participant is given a unique alphanumeric identification number that shows their transaction. Combining public information with a system of checks and balances helps the blockchain maintain integrity and creates trust among users. Essentially, blockchains can be thought of as the scalability of trust via technology. Next, we have the miners. So, miners are essential for creating the new blocks on the chain through a process that is called as mining. In the blockchain, every block has its own unique nouns and the hash, but also references the hash of the previous block in the chain. It means in the block we have three types of entries, that is the nouns, hash, and the hash of the previous block. Miners are used special software to solve the incredibly complex math problem of finding a nonce that generates an accepted hash. Because the nonce is only 32 bits and the hash is 256, there are roughly 4 billion possible nonce hash combination that must be mined before the right one is found. It means that is really typical to find the immutability into the after applying the mining into the hash. So there is a nouns that is 32-bit long, and the hash is long is 256, and roughly we have the like 4 billion possible nouns as combination to find out the what exactly was the mining. So making a change to any block earlier in the chain requires remining not just the block with the change, but all of the blocks that come after. That is why it's extremely difficult to manipulate blockchain technology. When a block is successfully mined, the change is accepted by all of the nodes on the network and the miner is rewarded financially. Here, what we can see how the smart contracts work. So here we have a register, there is a supplier and the customer. So matchmaking for the supplier and the buyer, there is a transaction receiving asset distribution. So that must be registered, automated settlement of the contracts, no third parties needed. So there is a total transparency, no miscommunication, efficient performance, no paperwork, backup, trustworthy, guaranteed outcome. So these are the most smart contract benefits which having the advantage over the traditional transaction. Now, what exactly is the main disadvantage that we are struggling with the confidentiality of the smart contracts error and the rock contracts. So, whereas most technologies tend to automate workers on the periphery doing menial tasks, blockchain automate away the center. Instead of putting the taxi driver out of a job, blockchain puts Uber out of a job and lets the taxi driver work with the customer directly. So this is the main concept of the smart work contract. So what we are doing, these kind of we have the strategy of the Zomato. So in the blockchain technology, customer is directly dealing with the supplier. There is no third party involvement into the smart contracts. So we have different use cases like record storing, trading activities, supply chains, mortgage, and then real estate market, employment arrangements, copyright protection, healthcare services, government voting, insurance claims, and the Internet of Things. So here, what we have seen that is the blockchain overhyped. So the truth is, no online database will replace your daily newspaper. No CD-ROM can take the place of a competent teacher, and no computer network will change the way government works. Since 2020, blockchain and the Bitcoin was on demand in the market, but still the implementation having the major strategical challenges. In the government environment. So here what we are between the disappointment and the production. So we have the expectation, disappointment, and the production. Now, what we have like proof of work blockchain. So that is a method employed by the blockchain to verify that calculation was successfully completed. So this is the proof of work. It means whatever the calculations have to be done, that is verified by the proof of work blockchain. Each node must demonstrate their POW to all other nodes on the blockchain in order to be given credit for their processing power. For the Bitcoin protocol, a value called now announce is added to the transaction ledger to find a specific hash property, namely a set number of leading zeros in the resulting hash. So here we can see there is a block which has the fixed value, then nouns, which is the variable, and having the hash. So here, some student has done this. So we have created the block, then nouns, and then data and hash. Now we have to mine the data, which has to come across way. So this is the practical distributed lasers. Each node maintains access to the distributed laser. New blocks are distributed to every node for processing. The ultimate objective processing is a reduced that proves that work applied to the blockchain proof of work. There are other forms confirmation that is a proof of stake. So here what we can see there is like Bitcoin market having the market cap, the most market cap is the dollar 53 billion, and the Ethereum is the dollar 24 billion as per the data of the 2024 statics. Here, so Bitcoin decentralized networking demonstrated the feasibility of secure applications. Show how to distribute and maintain an accounting of continuously added transactions. Blockchain technologies have expanded to and in many domains: decentralized banking, networking, security, identity protection, and distributed storage and the smart contract. So here we can see the proof of work monitoring. We have the real-time monitoring of the identification of network security, tracking of working efficiency, API development, and the improvement. So here there is this API is going to provide the mining capability with the credits, next block, active workers, and the shared. So here, the address generation is done by the random private key generation. So the generation of addresses for any blockchain depends on the implementation of the cryptographic algorithm. So, for example, in order to create a Bitcoin address for the sending and receiving Bitcoin, an elliptic or cryptographic algorithm is used. So, before an address can be generated, it is necessary to have a public-private key pair. So, there is a mathematical relationship between public and the private key pair, and but it is currently computationally infeasible to calculate the private key from the public key. So, ECC is following the Beer star form, and we have the Galois field where there is a certain multiplier application where we have to generate the public key from the we have the first public key, that is the x integer and the y integer. Then we are going to divide into the 32 bytes. Then we have the 20 bytes of the network ID, and then we have the SHA that is going to be like encapsulated with the 32 byte checksum. Then we have the 25 byte binary address, then it will generate the some address that is the hash value. So this is the generating Bitcoin address. Move your mouse around to add some more randomness. Okay, so this is how we can generate the Bitcoin address. So this is the public key, that is a Bitcoin address, and the secret key, that is a private key. So it was taken by the bitaddress.org. So that we have the blockchain security innovation, that blockchain based PKI certificate authority centralization creates a single point of failure, key verification through consensus, and then secure identities, data integrity. Hashing techniques must contain with collision avoidance, distributed data and comparison techniques, transaction signing. So blockchain integration. So there are the many projects which is associated for the blockchain integration, and there are the decentralized application that support a specific blockchain. So what can be decentralized, how can distributed application be decentralized into existing technology, what needs to change to bring about adoption, that is the decentralized application. So either ID, honest dice, notaire, ethereum, either cap. So these are the different decentralized application which is having the stated their kind of adoption. So what is the impact we are having blockchain effects on the cyber security, that exactly blockchain having the confirmation, open source confirmation of the transaction, and but we do not have many application for the decentralized, but a number of key cyber security application will benefit. Okay, we have the personal identity, data integrity and sharing, and the network security. So not non-Bitcoin blockchains are the Ethereum, digital cash, that is a private payment, Zcash, zero knowledge cryptography, Monero, that is a privacy, and Ripple, global payment blockchain, that is a Japanese banks, Augur, prediction market blockchain, that is a Ethereum based, IOTA, that is a IoT security, Neo, China's Ethereum. So these are the which is not following the Bitcoin concept, and they have made their own cryptocurrency. So here we can see like Bitcoin cryptocurrency has having the market dominance around 2013 to 2017 in the vast manner. So, what practical blockchain consideration, that how we are continuing the blockchain adoption, upcoming Bitcoin upgrades, cryptocurrency markets, and investing, corporate support of blockchain projects, and the regulation. So we have different verticals here for the blockchain digital transformation, that is the technology, media, law and crime, transportation, governmental services, human rights, financial and contracts, and the entertainment. So here we can see that when we are talking about the transportation, we are dealing with the government, traveling, healthcare, education. Okay, we have different kind of different sectors where blockchain having their more importance for the legal contracts and inheritance and the maintaining the immutability. Now, I have discussed that a blockchain came after the coming Web 3.0. That was the third generation of the internet where the devices are connected in a decentralized network rather depending on the server-based database. The new internet is a user-centric, most secure, private, and the better connected. So, in the 1.0 in 1990s, we had the basic HTML emails, and then Web 2.0 informative and the interactive, and Web 3.0 is the most user centric, that is the most decentralized, private, and the secure network. So Web 3.0 is the anti monopoly, pro privacy, secure network, data ownership, interoperability, no interruption in service, permissionless blockchain, semantic web, ubiquity. So these are the main benefits for the blockchain Web 3.0. So here we can see there are the decentralized apps. There, when we are talking about the Web 1.0 and the 2.0, we have the centralized internet, that is the central server, internet, and the devices. Here, after the introduction of the Web 3.0, we have the decentralized databases which are connected with the devices, and different devices are connected to the different decentralized databases. It means devices are more user centric and they have more capability for defining the new business models, new data flow, and new decentralized internet. So here we have the decentralizing everything, that having the ecosystem of social network, exchange services, messaging, storage services, insurance and banking, streaming services, and remote jobs, and the browser. So we can see that we have the different CryptoTask, Kyber Network, Riot, and the sign. Every laser is having the SafeShare, MediShare, SIA, Brave, Props, so different kind of D apps which is going to be introduced in the Web 3.0. So blockchain supply chain, mainly what we are doing in the blockchain, we are designing the supply chain task for the blockchain assets. So this exist in the digital inventories, tradable, that is flexible, fungible, and more importantly fundable in the global digital network economy. So, what it can it mean to supply chains? Difficult to monitor asset ownership and the transfers. So that is the inefficient misalignment and the expensive. Let assume, you are paying to the Uber, but Uber is having the distributed their taxi rider for taxi owner to the particular amount that is not to disclose. So this is we have the difficulty to assert the ownership and the transfer. So in the blockchain we have the synchronized consensus and irreversible prominence and efficiency to maintaining the lasers. So we have the blockchain streamlined supply chain, single shared business logic in blockchain cloud. So credential and private views issued to multiple parties in the blockchain value chain. So we have the customer. we have the regulator and the producer, factory, distributor, and the compliance body and the recycle on the same blockchain, and the particular laser is disclosed to everyone, and the same authority and same information is provided to each and everyone. So here what we can see, regulator is the has to create the entry and assign it to the producer. Then producer or factory make a goods and ship it to the distributor, update the laser and assign to it to a distributor. Then we have the distributor that is sells the item and assigns the variety to the customer. Then at the end to the life cycle of the product shifts the item to the recycling plant and updates ownership recorded by assigning to recycling. Then we have the recycling plant repurpose the material, the updates in the laser. Then we have the compliance body that can on regular basis review status of the item in the question. So that is the 1.0 basic better horse, that better internet, the payments layer the internet never had, application real time events and monetary transaction. Then 2.0, then advanced horseless carriers, that internet with value transfer and the smart contracts. So we have the financial contracts, that is the mortgage and the insurance, legal contracts, different government documents, voting. Then we have the 3.0 future car. New species of the technology invent new possibilities that did not exist before. So we have the large scale collaboration technology superseding previous social collaboration technologies, corporation, governments, and open source communities, application, automated fleet management, big health data, asynchronous communication. So we have the two main factors leading financial service implementation, that fintech, regtech, tradtech, and the health tech. Okay, so product fungibility, standard transaction language. So we have the different blockchain adoption by the industry till now. We can see financial services having the first priority for the having the blockchain implementation. Then we have the supply chain, and then we have the healthcare. So here we have seen that buyers and sellers, deep learning matches purchasers and the sellers, good more fungible than requirements, which is fine. Deep learning pattern recognition system, lack of trustworthy product information, attribute information, quality characteristics, provenance, and chain of custody is blockchain modulated for all goods. Lack of global digital contracting structures, digital product inventories, then blockchain-based credit histories, vendor payment channels, always on trade finance network, fundamental level of work, organization, item not invoice. So everything is a liquidity problem in the supply chain market. So here we have to procure the blockchain registered, digitized assessed, that is the ownership confirmed, ready for transfer, instantaneous global transactability, pre-validated, digital registered assessed, then financial implementation, then business process implication. That is the automated business logic via smart contracts, shared business processes in enterprise blockchain networks, shared record keeping in an era of blockchain ledger. Now the firm becomes an ecology, developers community, app store, revenue sharing model, user community, and supply chain is making the real global market. Now there is a challenge, what kind of public chains are there, what kind of the private chains are there, and how this supply chain has to be integrated in the healthcare solution. So we have the Bitcoin, Monero, Cash, Zcash, Ethereum, Otta in the public chains, Hyperledger, Quorum, Coda, and Cbnot in the private chains. So here we can see there is a P2P network confirms and record transaction. So we can see transaction submitted to a pool and miners assemble new batch of transaction each 10 minutes. Okay, so whatever the transaction is going to be there, so there is a transaction chain and new transaction are pending, and there is a maintaining the ledger in the terms of the block. Transaction computationally confirmed ledger account balances are updated. Each block includes a cryptographic hash of the last block, chaining the blocks and blockchain. PA nodes maintain distributed ledger. So we have the consensus algorithm, that is the public blockchain, POW, proof of work, Bitcoin, POS, proof of stake, Nextchain, then private blockchain and enterprise blockchain, that is the CODA, that is a simple notary, hyperledger, endorsement policies, Ethereum quorum, draft consensus, then Ripple are the validators. So enterprise platform comparison, when we are talking about the Ethereum, Hyperledger Fabric and Articoda, at the time of the implementation, we are like which kind of blockchain we have to follow. So if you are needy with the generic blockchain platform, then we have to follow the Ethereum. Otherwise, for the modular blockchain platform, that is the Hyperledger platform. And for the financial industry, specific needed, that Articoda is needed, and governance is taken by the Ethereum developers, and Hyperledger Fabric is the Linux foundation, and Ethereum are the permissionless, public or private. Hyperledger Fabric are the permission and the private, and Articoda also is the permission and the private. So consensus type mining based on proof of work, laser level, broad understanding of the consensus that allows multiple approaches. So here specific understanding, that are the notary node in the transaction level in the Articoda. Smart contract nodes are codes are done in the Solidity in the Ethereum, and when we are doing with the Hyperledger, then Go and Java are more compatible. Smart contract code are done with the Kotlin Java, and legal flows with the Articoda. Either tokens via smart contract are the in the Ethereum. There is no cryptocurrency with the Hyperledger currency and tokens via the chain code, and Articoda having no type of currency. So blockchain automation, current economy, business processing, reengineering, any complex transaction has two kinds of activities: steps with human decision making, steps that can be automated with the blockchain. Apple type design for user experiences. Okay. So like stock transaction, real estate purchase or sale, health insurance billing, energy contract, international trade shipment. So when to use blockchain technology? Blockchain is enterprise software, solid business use case. How does this decentralized solution improve over a centralized one? So this is the main main agenda, that if you are having the blockchain, okay, you are acquiring the blockchain, why it is needed, why this decentralized solution is needed over the traditional one. Ideal use cases, many parties in the value chain, intensity of information and monetary exchange. So use health insurance claims billing, that is the Factom. Okay, so Factom overlay to Bitcoin blockchain, so it automates the claims billing, validation, payment, and the settlement. So Factom is the healthcare industry example, that maintaining the health insurance claims billing, that there are the multi-party value chain patient, service provider, billing agent, insurance company, payer, government, and the collector. So this Factum is providing the automation of the billing, validation, and payment and the settlement. So here, after implementing the blockchain, we have to go with the smart contract marketplace. So we have to either Dockerize the container with the cloud solution, Azure, Ariba, or Busware, interface to web CRM and ERP, AR or AP. Then interface to data analytics, that is my machine learning for real-time fraud detection, real-time patient monitoring, or real-time billing monitoring. So here we have the blockchain tools, that are the smart contract based and distributed ledger stacks, consensus, networking database, third party DL stack, and then adapters. Okay. So after that we have the blockchain marketplace. Okay. Distributed ledger gateway services, identity and key services, then crypto services, ML and BI services. Then we have the SaaS solutions, and we have the different domains on the IT stack. So after the fintech and after going through the different kind of chains, So industry adoption is taken care by the payments, financial services, logistics and the supply chain, energy, IoT, healthcare, government and humanitarian, non-profit. Application are the cash, smart asset, smart contracts. Okay. So immediate cash transfer, financial instruments, then assets are the goods transfer and assurance, provenance, commercial trades. Contracts are the BOL for equity, insurance inventory. Registries are the titling, house auto, public documents, marriage license, birth document registry, identity, driver's license, passport, visa. So we have seen that the secure information exchange, asset and information and transfer, automated coordination. That if we are having the autonomous driving, robotics, clinical trial of the patients, cellular therapeutics, and fleet management of the drones. So we have the automated coordination with the blockchain functionality. Blockchain are the automated secure coordination system with remuneration and tracking. Here, these are the example for the clinical trial of the patient at the time of the COVID, the last diagram. So this machine is provided with the for the blockchain integration, where each patient has to maintain the blockchain with this clinical trial time. Now, coming over the healthcare 5.0. 5. Healthcare 5.0 is integrated with the society 4.0, that interests of citizen form the starting point of building the society. Regions form the basis of form the future citizen society, as several technological developments enable the decentral production of most primary human necessities, from energy and food to health and education. So this is like Society 4.0 supports initiative that helps the rebuilding of the regions by inspiration, knowledge exchange, networking, expertise, actions, and the concrete solution and financial support. So the foundation of our future society needs to be rebuilt from the basic needs of the citizen. So here we can see in the industry 4.0 we are integrating the different technology after the adoption of the automation, computer and electronics in the industry 3.0. So industry 4.0 having the society 4.0 sector aligned, where the first sector is coming to the health and wellness sector after the governance, history, tradition, religion, health and wellness and the science. So and these sectors having the different kind of layers, that is agriculture, transportation, trade, telecommunication, then military, defense, education, learning, construction, and the justice. So here we have to need for modernization in manufacturing, launch initiatives to promote computerization, automating in factories, personalized production in the industry 4.0. Now we have to see the particular application of the machine learning. So when we are talking about the machine learning application, we have like virtual personal assistant, we have the self-driving car, product recommendation, speech recognition, image recognition, medical diagnosis, automatic language translation. So the term that introduced as the healthcare 5.0, that is to make healthcare more patient centered, so that they will be the protagonists of their own care. This means that patients are actively involved in their treatment. This happened because nowadays we have the lacuna of the producing doctors and the hospital industry, wherever we are having the more disease intended patients approach. The approach aims to create an intelligent and secure system from scheduling appointments via telemedicine or at the doctor's office to giving the doctor access to the patient's information in the office. To ensure the fluidity of the process, Healthcare 5.0 combines technologies such as blockchain, virtual and augmented reality, AI, and IoT, which were used in Healthcare 4.0, also play an important role in the performance of the smart healthcare. So I must say that when we are talking about the blockchain and the healthcare, So blockchain actually introduced in the healthcare 5.0 rather than healthcare 4.0. Healthcare 4.0 was restricted with the medical diagnosis, with the implementation of the AI and the machine learning. Now we are going towards the blockchain integration and the AR VR technology. So here we can see that healthcare 1.0 was focused on the evidence based treatment model, and strategic differentiator was the patient survivability. Healthcare 2.0 was the industrialization, that is the focus of the value chain integration model and to end service coverage. Healthcare 3.0 was the automation that focus on the operating model, and we have the strategic differentiator cost to serve efficiency. Then we have the healthcare 4.0, that is the mass personalization. Hello, hello, hello. Okay, fine. Thank you. I think I was disconnected 1 or 2 minutes ago. Let me talk about this slide again. I think I was audible this till this time. Okay, fine. Thank you. Just a second. So, when we are talking about the healthcare 5.0, that is more intended about the personalization, that to focus on the customer model, and that having the strategic differentiator, that having the personalized um, of the quality of the life because of the daily day-to-day eating habit, or day-to-day like day-to-day fertilizers involvement in the agriculture, mass mass production of the like grains and the other type of fruits or vegetables, or whatever the industry you follow. So this need customer model with the focus on the um, mass personalization, focusing on the customer model. So, actually, block. I was already telling that like when we are talking about the healthcare 4.0, it was restricted with the involvement of the AI and ML, and after the integration of the blockchain, that comes into the healthcare industry 5.0. So, health industry 5.0 provides a product to the customer as per their specific requirements. The complete focus is on healthcare professional and the patients, their lifestyle, well-being, health analytics, quality of life. And it is also called as the health 5.0 and industry 5.0 and the healthcare 5.0. So data is the new oil and artificial intelligence is the new electricity everywhere. So we have every prominent technology of the industry 4.0 is intended towards the data. Okay, so here we have to personalization of the health data. That means I need a transparency, I need a security, I need the identity management with the integration of the personalization of the customer model approach in health industry 5.0. When we are talking about the care 4.0, industry 4.0 and health 4.0, we had the stability, pressure, and then precision medicine, clinical optimization, clinical care, hospital patient. Okay, industry 4.0, we had the agility, then market focus, customization, competitive advantage, manufacturing, factory, and consumer. Care 4.0, we had the person, community, co-managed care, and empowerment, personalization, complexity, and the flexibility. It was given by the Chitan France in 2018. So, we in healthcare 4.0, we had the applications of AI that we have like diagnosis and the treatment with the clinical decision support, symptoms analyzer, treatment efficacy versus effectiveness, computer vision, radiological image analysis, that is ECG and the EEG. So it is more inclined to the accurate accuracy and the precisionness. Workflows, patient flow optimization, detect process, identify inefficiencies, predictive modeling risk stratification. So readmission rate, hospital acquired infections, emergence of complication. We have the virtual assistants, then mobile applications, well-being, chronic disease management, then precision medicines, then genomics, then discovery are the clinical trial, hypothesis generation, proof of concepts. Okay, so matching engines, patients with similar profiles, treatment with the similar cost benefits ratio. So when ML algorithms were implemented into the healthcare, so diagnosis and disease identification were done, predictive medicines are ongoing, medical care personalization are ongoing, administrative workflow also ongoing, medical image analysis, drug discovery, and medical documentation flow. So these all are the algorithms which was involved in the healthcare for application fields. So we can see what exactly is the digital healthcare. That is the deep learning, machine learning, and AI. So we have the patient data management, next generation sequencing, imaging in digital pathology, drug discovery, and precision oncology. So my thing is that how I have to introduce in these all scenario into for the blockchain and why it is the needed. Okay, when I am going to find the blockchain application, blockchain mechanism, why it is needed to introduce in such kind of digital healthcare in healthcare 5.0, when we are talking about the patient centric approach. Okay, so when just take an example of the drug discovery. Okay, so drug discovery is the there are so many clinical trials are made, and every different kind of ventures are involved in those kind of drug discovery. Okay, so managing those kind of records will be held out by the blockchain for maintaining the immutability and the tracking the first transaction was made in the record by the maintaining the blockchain. Here, the an application which is already been done by the Startweek, that vaccine and cold storage tracking. There are so many drugs diabetes or other kind of drugs which require the they are maintaining the storage and their temperature. So cold chain is a temperature constrained supply chain used to store and transport perishables such as food, vaccines, and other biological products. So 50% of the management of cold chain for biopharmaceuticals such as vaccines is challenging. Globally, nearly half of all vaccines are last when exposed to the unsafe temperature ranges. 80% of the blockchain cold chain accounts for around 80% of the total financial cost of vaccines, making vaccines more expensive and less accessible to people in the developing world. Industry reports indicate that nearly 30% of the food is lost every year due to the inefficient cold chain supply. So, what we have to do? We have to integrate the IoT with the blockchain registered IoT attributes, temperature, pressure, and the geolocation and the custody for maintaining such kind of temperature and increasing like if this is like temperature and we have the sensors and the different type of tracking ability in the my IoT gateway. So I can maintain the temperature while sitting online. So this is the chain of custody, then financial services, embedding distributed laser technology. So here, Ripe.io that having the different history of the data, blockchain of food, which is given by the Ripe.io. Now, we have just integrated forecast, demand, and supply chain management system. Exactly what we are doing, we have to maintain the either the cold storage supply chain, either the food storage supply chain. So there is a trusty value chain by using recurrent neural network, which contains enough memory, gated connected units, and genetic algorithm. So it was like given an example by the proposed structure. Especially agricultural products are always undergoes safety clearness. It is mandatory to ensure quality in order to maintain balanced food supply chain process. So two types of functions are allowed. That is enterprise resource planning, which includes product visibility, digital currency provenance, virtual custody chain connection, and smart authentication that includes data from IoT devices about temperature, hardness, water moisture, and the soil nutrition. So here we have the cloud storage and the blockchain that producing the smart contract transaction and consensus ledger. Then we have the trusty firewall that having the trusted computing. Then key management services. Then we have the client application, data owner, data consumer, and the enterprise application that are communicated to the trusty firewall and directly communication with the cloud storage also. So here we have the identity management system for endpoint security via the blockchain network. That blockchain network is having the digital flow, physical flow, and the registered item with the product verification, distributed network, and the retailer market. So here we have the advanced machine learning flow in the same supply chain management that we have the test data and the train data. We have the modified GA, fitness function, and the mutation. Here we have the train data that having the parameter selection RNN, and we have the fitness evaluation. So if these are the satisfied, this is again going with the test data. Then we have the optimum parameters for learning strategy from the machine learning. So here we can see the blockchain economics. Ownership are confirmed instantaneously, transactability, global smart contracts, crypto tokens are there. So we have the net settlement, adapt, payment channels, securities as a service, real-time balance sheet, black swan smart contracts. Now financial and the participation, initial coin offering, open platform business models, and then we have the enterprise blockchain, single shared business processes, integrated ledger, smart contract, document exchange. So when we are talking about the blockchain is not for making quick money, a way to privately send data over to network. The solution to our world's economic or global crisis is it's not for the blockchain. Why we are using the blockchain? A way for peers to reach consensus and authority free network and open source mathematically based solution. This is the main agenda why we need the blockchain. So now what are the challenges that we have the digital fingerprint, digital signatures, consensus. So what having an overview, we have the different Bob, Alice, Charlie, Dave, and they have to manage their secret key over a network, and how they have to maintain this key with the consciousness. So broadcast transaction using address and sign using private key. Okay, Alice is doing this. Bob verifying signature using public key. Charlie transaction and lasers are fingerprint using CHF. Okay, so now DAV is the party which is going to write all about of the consensus. So Bitcoin was the first example which what we have seen that algorithm prevents the double spend problem. The intuition is that transactions have to be time stamps and trust based um, on the entire network. Security is guaranteed if the number of honest nodes is larger than the number of malicious nodes. So Bitcoin is a chain of the networks, list of transaction, a hash of previous transaction, and we have the proof of work. So in the transaction, we have the owner's first private key, or owner's second private key, owner's third private key. We have the first public key in the transaction hash and owner's zero signature. So every block containing the previous hash, nonce, and the transaction. So this is the how we are containing the block. Now we have the Bitcoin proof of work, that is the high level idea, proof of CPU effort. Solving a puzzle is attached to the block. The block cannot be changed without redoing the work. After chaining the other works, it becomes even more difficult. Okay, so we have different kind of SHA integration with this proof of work. So, what to incentivize the network to perform this computation? So, expanding computational power. One answer is simple: to be able to use a secure network of value exchange. Another, less idealistic net reason, is that nodes that verify transaction, that is miners are rewarded with bitcoins when validation of block. So it means we are providing the reward strategy by mining the target binary output. We have to maintain the puzzle difficulty so that mining cannot be done by the third party. Okay, so entire network. So every node gather new transaction in the blocks. Every node tries to find out the POW for its block. When a node finds a solution to the POW, it means if I am verified merchant over the network, so it is really I have to build a difficult cryptographic algorithm to find out to distribute the POW and find out the solution which is transmitting over the block. Nodes accept a block if all the transactions are valid and not already spent. Nodes express their approval of the block by using its hash as the part of the later transaction they process. In case of conflict, temporary branches can be created locally. So bitcoins which that claims that they are saving the disk space, all transaction can be discarded. A market tree structure is used so that the hash of the tree is not to be changed. So we have the pruning all transaction, we have the transaction 3 with the hash 3, then hash 2, then we have the hash 2 3 hash 0 1 with the root hash, then previous hash and nouns are integrated with the block rather than the all transaction block. So this is the privacy in the blockchain: identities, transactions, trusted third party, crypto counterparty. Then this is the public in the traditional privacy model. In new privacy model, we have the identities, transaction, and the public. All other things are demised. So we have the because of the consistency requirements, all transactions should be made public. Asymmetric encryption protocols, then along with the firewall, can protect and the identity of the users. Blockchain architecture with the Bitcoin. So we have to broadcast the my Bitcoin that verify signature using public key with of the allies, and that can be used for the transaction. Now when we are seeing the Ethereum as a smart contract, Bitcoins are the consensus in the network without the need for a trusted third party. But consensus is limited to simple transaction. More complicated rules such as conditional money transfer or online voting can be implemented. So Ethereum was developed with the idea further to allow consensus on code that is written in 2014. So private keys own simple values. Even in the Bitcoin and in the Ethereum, we have the private keys or accounts. All values are owned by a private key in the Bitcoin. There are externally owned accounts and internal accounts then cannot be called directly that in the Ethereum. So, when we are talking about the Bitcoin as a state transition diagram, so in the state we have the public keys and transaction. We have to span signature, then we have to state. Then in the Ethereum smart contract, we have the state with the different keys, then transaction from as we have discussed that we have the public key address to value data and signature. Then we have the state different states. So, what is wrong with the POW in the case of the Bitcoin? So, in POW, the algorithm rewards participants who solve puzzle to validate transaction and creates new block that is called that's a mining. There are only 21 million Bitcoins that can be mined in total. Miners will still be incent, um, incentivized to validate the Bitcoin blockchain because they will collect transaction fees from users. The fact that Bitcoin is capped means it was thought as a deflationary economy. POW consumes large quantities of the electricity. So, proof of stack, instead of relying on computational work, proof of stack choose the validators randomly, but with probability associated to with wealth or age. So, this is like participating nodes are called validators in the proof of stake. Validating capacity depends on the stack in the network. No new coins are formed. Validators receive transaction fees, low to moderate energy consumption. 51% attacks are virtually impossible. So, like what in the proof of work, we have that significantly prone to 51% attack and that needs the massive energy consumption. Miner receive block rewards. So properties, we have already seen this. I'll not discuss this once again. Now we have like healthcare application. So this many application, medical insurance, medical supply, IoT related, electronic health records, patient specific, some ownership and control issues arise. Am I audible?
Yeah, you are audible. Please continue.
Yeah, thank you. So we have to maintain the electronic health records as the data are sensitive and patient specific. Some ownership and control issue arise. The blockchain has been used in several studies to guarantee data ownership and access control mechanisms for the patient. So these are the prominent healthcare application which is governed by every sector. So here in the traditional architecture for EHR, what we are doing, we are going a hospital. Okay, a patient is visiting to the hospital. After that, a hospital is maintaining the data. Okay, in the blockchain based architecture, a patient is having the ownership of its own record. Okay, and after that, it is also distributed to the same ledger by the same ledger to the hospital. So hashes of the data are stored on the chain. Ownership can be proved. Access control can be managed. Data modification can be detected. So here we can see there are some blockchain based EHR literature. So different identification, verification, access policies, providers, DB storage, digital signature, symmetric and asymmetric encryption Ethereum by given by the Jan et al. In 2018. And however, there are so many literature which are available. for the EMR records and auditing records and data access policies records. Now, the main question is that why we are using the blockchain for maintaining the electronic health record. Is this a essential purpose for using the blockchain, or just we are there is a development of a technology that is a blockchain, and that is integrating in the healthcare 5.0? That's why we are going to integrate the blockchain into the healthcare sector. No, this is not just the case. When we are just seeing from the 2020, there are a number of cases which are proof of the attacks on the AIMS database. There are the AIMS patient monitoring database and health records, which was attacked by the China's agency. There are so many cyber security attacks which are done on the healthcare records over the world. Okay, from 2020 to 2025, I think there are 3 to 4 attacks which were done only on the healthcare records. Now, what are the advantages for these healthcare records? See, when as a security or cryptographer or blockchain professional, when I'm seeing that an agency is thriving for the such kind of healthcare records, he is just monitoring which kind of disease geo spatial location patient is struggling. Okay, and there is a use pharmaceutical industry is associated via these healthcare records. Okay, we have seen in the COVID, whatever the reason was for the COVID, but major advantage was gone to the pharmaceutical industry. Okay, and how we are immutable or mutable, which kind of disease, this is done by the monitoring of the healthcare records. So here French use case, blockchain based personal health records for patients empowerment, EL Rifo at al. So, with blockchain, we have the HCP smart card. Uh, First, we have the patient portal. So, CNAME server and other government accredited data providers are there. Then, patient have the web access. Then, patient smart card is there. That is a carded filter. Then HCP smart card is used for the identification and authentication of the digital signature. So, and this digital signature platform is integrated with the HCP platform, DMP access via DMP compatible solution or the web browser. So, access and control mechanism are unilateral. All identities hosted on servers, record securely and immutably, can be compromised just attacking the CNAME server. So we need the access management. The blockchain can host data hashes and user defined access control policy. Data hashes fingerprint their medical records, guaranteeing that the original copy is never tampered with. Access control policies stored on the blockchain would serve as immutable reference for the access rights. Transactions are natively immutable on the blockchain. Patients are guaranteed data logs are not tampered with. So, should your project use a blockchain? Are you making the decision using a flowchart you found? Yes or no? Definitely, you are. So, we have seen that how the supply chain becomes a demand chain. So, here, fundraising methods are there more liquid than equity. Then, securitized customer demand, financial model, pre-sale access that are going to monitor the product development with the equity ownership, product token, and platform. Now, why I'm discussing this? Because there is a major integration of the supply chain in the medical and the healthcare market. So this first I'll discuss with this Pharma Trust. Okay, this is developed by my students, and this project is actually on the protocol stage, and they are working on this. Like what we are struggling with the counterfeit drugs. These are the fake drugs that are available in the market on the very very much in the manner like everyone is selling these fake drugs without any authentication. Okay, now these are called as the counterfeit drugs. Now what kind of struggle a customer is having, like what you are as a patient, I have gone to the medical store and I have purchased some like just to have an example of a Dolo. Okay, Dolo is a medicine which is used for the fever. Okay, now how I'll just how I'll mark that it is the authenticated Dolo which is produced by the first manufacturer. So this is really a questionable thing that the customer actually deal with, that there is a lack of tractability. So 50%, 27.5 million counterfeit medicines retained by the authorities in the previous era. 36% of anti-malaria drugs in Southeast Asia are falsified. 9.8 million illegal and counterfeit drugs seized during Panga's sixth operation. 50% of cases medicine purchased over the internet from illegal sites that conceal their physical address have found to be counterfeit. Up to 30% of medicine in developing countries are counterfeit. So there is cumbersome compliances, like payment duration are the 30 to 60 days, lack of transparency, bad inventory, lack of tractability. So now what exactly is the solution? Okay, like what whoever is the manufacturer and they are providing these medicine from the manufacturer via the medical store to the there are several parties are involved, till from the manufacturer till the customer. Okay, so we have to maintain a blockchain consciousness so that a patient is directly going to the medical store, and when it is dealing with the QR or some kind of identity over the medical drugs which is associated with the manufacturer, is easily identified that it is not a counterfeit drug. So what we are doing that existing system is interacting with the user. Okay, so hospital, manufacturer or the shipping company, so we have to integrate with the sensor data, then with the interacts with the metamask, then metamask particular maintain the identity, interacts with the smart contracts. Okay, then there is a through API and functional cones, trigger events and the database. So here we have the AWS that is hosted on, and then manage that manages the blockchain. Layer 2 is the Validium, so which stores data on layer 2 ZK that is called as the Validium. So this smart contract is designed with the MetaMask, and that manages the blockchain on the AWS. Now what we are doing, we are hosted on the existing system that interacts with the user, that hospital, manufacturer and the shipping company easily monitored what exactly is. The user need not to worry about the originality of the drugs. So this is pharma trust. Next is I have developed with the six degree of the freedom of the robot for long bound reduction robot at the tenure of my postdoc from the School of Engineering and Digital Sciences, Nazarbayev University, Kazakhstan. So here we have seen that when the data is given to the over the cloud, so we can maintain this data over the cloud for visual assistance via the blockchain. Okay, so this can be the visual therapy that integrating the blockchain for rehabilitation functionality purposes. Next is the this is the physiobot that is also worked by my one of my students, that he has designed that whatever the therapist is actually is sitting on the virtual side and doing the action in and the same action were taken by the implanted robotherapist with the help of the actuators, robotic arm controller, then central nervous system, muscles, then physiological sensor system, musculatin system, human robot system, robotic arm system. So for the easiness, via the strengthening the ADL, what we can do, we can integrate the blockchain for maintaining the authenticity and the transparency from the video and the voice recognition. So this is also the medical healthcare application where these are the assistive limb are used for the angle sensors and exoskeletons are there. Intuitive surgical, dimensional surgical robot. These are the examples. And now these robots actually for maintaining the health records, for maintaining such kind of record, what exactly the data has to be taken in the account, we can use the blockchain here. So drug discovery also there for maintaining the records, testive sorting. So another is the mind controlled arm processes. So here data cannot be modified, whatever the device has to be implemented. So this is a cognitive computing. So if this data has been monitored by the attacker, so there is a harm for the patient. So what we can do, we can implement the blockchain for the processes aim for the controlling over the processes aims by directing connecting to the user brain signals. So this is what exactly, and there is a 3D bioprinting. So 3D bioprinting pacemakers and other devices we are using. So another thing, how we are actually comprising our blockchain for this 3D bioprinting for maintaining the organ implant function. Okay, so this is also a highest need of the security because there was a case one patient was dead by the attack on the pacemaker, okay, with the security cyber attackers. Okay, so by maintaining the blockchain over the pacemaker, that integrates with the security. So procurement leading the path ahead, procurement already automating the efficiency associated with sourcing and purchasing, global reach, sophisticated business technological intensive solution, real-time exchange, challenges to envision, and continuing leading the modernizing way forward with the strategic equity. Thank you so much. And there are also ethics are involved when we are taking care about the AI, machine learning, and this kind of healthcare 5.0. So we need to maintain the blockchain application for ethical who is actually the person which is and whom we are dealing with. Thank you so much. If there is any question. Hello, I'm audible.
Hello.
Hello, sir. Good afternoon. Good morning.
So thank you very much, Dr. Aditi, for giving us this valuable talk on this AI in the healthcare. I will like to uh, state that the Dr. Aditi is a uh, a core connected faculty in our multiple such type of the faculty development programs, and she has enthusiastically participated in this, and she has delivered the wonderful talk pertaining to these issues in the